Alright, we are recording. So first things first, this is lenticular dust in detail, NGC 4753. It's really, really neat. So this video has a little bit of funny history. I am re-recording it, so it's been a bit since I originally did this recording. But originally, I didn't intend to do a second manufacturing video so soon after the ship design manufacture video. But literally days after I recorded that one originally, I've also re-recorded that, I saw the news that they have successfully, and this is going to be old news, it's from June 3rd. By the time this video comes out, that'll be weeks in the past. But they have actually succeeded in 3D printing metal on the space station, on the International Space Station. And it's like, well, I actually, in a letter from Catherine, do describe somewhat how they do some of the manufacturing on a space station. It's rather different, a bit more advanced, but let's talk about what was actually achieved in reality. So yes, as I said, they 3D printed metal, and the way it, and I'll try to remember to include the link to the European Space Agency, ESA, I say ESA, hopefully that's right. But in their press release, they do describe that they use no, it is stainless steel wire that's fed out into the printing area, and a high-powered laser that melts it. And then, you do that to build it up. Very similar to when you're using a plastic filament in what most people would know for 3D printers. For that, you're melting, at least partially, the plastic there, so that it will adhere to itself and build up whatever shape. But that is a bit different than working with metal. So yeah, definitely an impressive achievement, and one that ultimately will be necessary for space travel. That's part of the reason why I do describe in a letter from Catherine that you do manufacturing, including additive manufacturing, makes perfect sense to do in such a resource-limited environment as a spaceship or a space station. But yeah, additive manufacturing makes sense there, and it needs to be on there because you're going to need to be able to make new parts. Now, what I describe for my space stations is that they are also economic centers. They're like entire cities. So it makes sense that you would just be manufacturing things there because you manufacture things in cities. But it is also like, maybe you need to repair a part. Well, you need some way that you can make it. And additive manufacturing makes sense because, as I said, you're resource limited. You can't just be like, oh, well, we'll just make a entirely new sheet here by just taking a big block, cutting it off, and forming it, or doing no, you can't rely on that because you have limited resources. But additive manufacturing typically involves very little waste. You might need support structures, although since we're talking about space stations that do have their own artificial gravity that you could turn on and off, maybe even that you don't need. That's actually an interesting idea. I haven't really thought about that previously. But in any case, yeah, so 3D printing would make sense there because the material that you're using is the material for the final product. It's not just something that could be wasted. But what I describe is not like this, where they would have a metal wire that's being fed out, specifically stainless steel. So that's a certain alloy. This is important. A certain alloy that you're feeding out that would then be melted with a laser to build something up. No, it's actually what I mainly describe in there, and I'd have to review the book to know if I specifically use the term sintering. But in theory, as I looked into sintering more so recently, I've known what it is for a while, but it might not be what you'd always use. You might use something a little different, closer to this, where you would completely melt it. But in any case, sintering makes sense because it actually, the raw material used are metal powders, in this case, not a wire, metal powders. That's what I describe, and this is for a couple reasons. It's kind of the same reason. The way that they're transported there is actually as metal oxides, because oxides, why do things rust? Because it's more stable. The oxidation on iron, for example, iron oxide is more stable than just raw iron. If it weren't more stable, if raw iron were more stable than iron oxide, rusted iron, the rust wouldn't form. That's just how physics and chemistry works. Sorry, so you would have powders, because that can be fed into a system and measured very easily, are just shipped to space stations in very large containers. And then when it gets there, you would leave it until you need it, at which point you would then reduce the powders. So reduction is where you actually will strip off the oxygen. So you would de-rust it. And this is real. It's oxidation and reduction are two different halves of electrochemistry. It's been a long time since I took my AP chemistry course, but I do remember that section decently. Yeah, so you would reduce it then, being left with the pure metal. I've been talking about iron, so the pure iron powder there, and then that is what you would sinter together. Now, sintering is basically where you would have those powders, and you heat it up. It also mentioned applying pressure, so that the pieces they don't necessarily weld together, but they will start to align together and grip. And one thing about that is it does mean that the volume will also decrease. So you could 3D print something with sintering. It might not be something you'd want to use like to keep air from going through it. Might be able to go through there, but excuse me. One use for sintering is in heat pipes for some coolers that are in computers, because the surface area of these particles, because you're not, like I was trying to demonstrate here, you're not going like this. It's not completely welding. There are gaps there, so it's a high surface area, which is perfect for heat pipes. Other heat pipes, though, have actually a specifically formed pattern, so sintering is a bit different. But in any case, that's something separate. When you do need something that would be completely solid, completely welded together, you would just use a higher temperature that actually melt the metal so it can be welded together. Now, there's another thing going on here that is also why a stainless steel wire is not what you would want in this circumstance. Because remember, this is a well-established technology for this space station. Like, it's already been figured. It's a new space station. It's not one of the first ones. So it's like there's been a lot of development time to figure this out. It's using what's being sent there are pure metal powders. Well, pure metal oxide powders. I might start interchanging metal and metal oxide here, but it gets reduced down. You would have that mixed. You would make the alloy on site. Stainless steel, well, steel itself is an alloy of iron. Stainless steel is a specific alloy of steel. Which I know chromium is part of it, and well, steel is iron with some amount of carbon. And stainless steel, I believe it is chromium that's being added in there that produces the stainless effect, where it should not rust. And there's so many alloys of steel, so many alloys of other things as well. I believe you can alloy aluminum. Titanium alloys, as I recall, do exist. Copper, there's alloys of that, like brass and bronze are both alloys of that. So instead of shipping, here's a hunk of steel, here's a hunk of bronze, you instead ship, here's a bunch of iron. Carbon can come by another means. Chromium, and then here's the bronze, here's the tin, here's the zinc, here's the lead. I think lead is used as an alloy, as a material in some alloys, but in any case, you'd ship those all separately, because that way, hey, we need this specific alloy. Okay, we take 3 parts iron, 1 part carbon, which actually is stupid high amounts of carbon. It would be more like 3 parts iron, a pinch of carbon, and then a smaller pinch of chromium, and boom, we get stainless steel. I'm pretty sure I have that kind of I could be wrong. The specific values, I'm not a material scientist, I'm sorry. But the specific values there aren't specifically relevant. It's just, you would make it on site. And then with this additive manufacturing, whether it is you're sintering it or specifically melting it, so it's all welded together perfectly, that's what you would do. That is what I described being done there. Because it honestly just made the most sense to do. Yeah, 3D printing is, whether it is of plastics, of metal, as was achieved on the International Space Station, and also concrete. Some of you may not realize this, but there actually is 3D printing of concrete. The idea there is, it's a very large apparatus, but you could have it print up an entire building in hours. And you then just have it do that and move on to the next one, move on to the next one, move on to the next one. It's like you could do all that. And also, by the way, concrete, yes, I do talk about that being used in space stations even. Because why wouldn't you? I mean, there's a lot of things you can do with concrete that are very useful. So why wouldn't you continue to use the material in outer space? You might not use it on the outside because you may not want it. I'm not sure how permeable it might be for atmosphere leaking. But for interior walls, there'd be no reason not to use concrete unless you want to use a different material that may offer other advantages. And one thing I do remember I mentioned, that I will stop at this. I'll try. In a letter from Catherine, Roman is just musing on, I guess, the way to put it, and sharing with the reader things he has seen, other space station designs. He does mention that there's one design that he gets that it is good looking. He gets how it is aesthetically pleasing, but he also finds it really uncomfortable to be looking around inside of a space station. It's like, there's a window, and there's outer space, and it's wood. He doesn't like that, because, like, wood is permeable. So he knows it's just like a veneer there. He knows it's not the actual material, but it still is kind of weird to him. So he doesn't really like that. But it still is. You could use wood. Why couldn't you use wood for interior walls in a space station? Just like, in a building. In a building on Earth. I mean, there's no reason you couldn't. But exterior walls, yeah, that freaks him out a little bit. So yeah, that is this video. Not sure when I'll do another manufacturing one. Not sure what additional manufacturing topics I may have in mind for this stuff. But yeah, in any case, see you then.